I'm Damon Smith, Extension Field Crops Pathologist for the University of Wisconsin. We're going to talk today a little about soybean diseases and also soybean disease management. So managing soybean diseases is important because a lot of the diseases we have out there can cause quite a bit of yield loss in soybean. And the losses can vary across the state from year to year, but good diagnosis will help us in our disease management strategy. So I want to take some time today to talk about that. Also, there's really no silver bullet out there for taking care of every disease on soybean, and so we need to be able to diagnose each of these diseases in order to develop a tailored management program for that particular pathogen. And the best approach to managing soybeans diseases is starting with knowing what is causing the problem on that plant so that we can formulate that disease. So here's sort of my bulleted list of things to keep in mind when trying to develop a management plan. Make sure you get good identification. If you can't identify the problem, make sure you're using a good reputable diagnostic lab which can help you diagnose that problem. Utilize resistance. I think genetic resistance is the foundation of any good management plan. So look at variety trials and try to choose varieties with the best resistance package for the disease that you're trying to manage. Crop rotation can be very important for a lot of these diseases, and in order to get the field out of soybeans for a year or two will help reduce the amount of inoculum for a lot of these potential pathogens of soybean. Tillage can be important, improving water drainage. Also balance soil fertility to reduce stress on the plants. Occasionally, fungicide seed treatments can be useful for certain pathogens. Foliar fungicides may need to be used, especially for things like white mold and soybean in years where we're going to have weather conducive for that particular disease. And then, of course, good production practices that preserve good seed quality. And also plant density and seeding depth are going to be important here to give you a good head start on soybean disease management. Now here's a list of some of the important diseases that we do see on soybean in the state. So we have PHYTOPHTHORA root rot probably being one of our primary seed and seedling diseases in the state. Sclerotinia stem rot, also very important. Brown stem rot, stem canker, and then also soybean cyst nematode. So let's talk a little here about PHYTOPHTHORA root rot. In 2005, losses due to PHYTOPHTHORA root rot were somewhere around 39 million bushels. The primary pathogen that causes PHYTOPHTHORA root rot in soybean is Phytophthora soji, and this fungal-like organism can infect the plants at all stages of growth. So we can see seed rots damping off, and then later in the season we even can have some root and stem rot issues. Occurrence is typically in fields where we have poor internal drainage or standing water or water flows in a particular field. This particular group of organisms loves waterlogged soils, and so in those areas where you have saturated soil conditions, you might expect to see higher levels of PHYTOPHTHORA root rot. Here's some of the damage that you might see from PHYTOPHTHORA root rot. You'll notice that you can have emergence issues right from the seedling stage, maybe some damping off once the plant has emerged from the soil, and eventually we can have stem lesions which can form later on. Mortality again is prevalent in those wet areas, and in terms of management, we do have good resistance out there for the various Phytophthora races that can be found, and that should be documented carefully in a field. Make sure you diagnose that you have Phytophthora so that you can choose the right resistance package. Also, there are some seed treatments available which also can be very useful for Phytophthora. Now, some other pathogens can cause diseases which look similar to Phytophthora, so this table sort of gives you an idea of what to look for when you're trying to discern between Phytophthora and some of these other important diseases such as Pythium, Fusarium, or Rhizoctonia. Typically, Phytophthora, you're going to see it mostly in warm, wet soils, less so in cooler, wet soils. And so that's what really differentiates a lot of the Phytophthora diseases from Pythium, is just simply the weather conditions that prevail. Again, both love water, but the temperature is what separates the two. Now, Phytophthora can cause, again, those lesions on stems. They can cause that root rot and also seedling rot, just like Pythium. So it can be difficult to tell the two apart, but again, that temperature condition can get you started in the right direction. And as you can see, that's much different than what you might see out of Fusarium, which doesn't typically cause a seed rot for us, or Rhizoctonia, which is primarily more seen in warm, wet soils, and also causes a seed rot. So again, management options here include using high-quality disease-free seed, crop rotation, trying to manage moisture in the soil, maybe trying to put some drainage in areas that are consistently wet in a particular field, and then of course resistance is going to be very important. Fungicide seed treatments can be useful on soybean for managing this disease, because a lot of times we may be forced to plant early or into cold and wet soils, which can predispose those plants to damage. Reduced till and no-till fields can also be more conducive for this particular disease. We may also want to use seed treatments if our germination is low, okay, because that indicates that we have some low seed vigor there. Also, if we've had a previous history of some issues, not only with Phytophthora but other seed rot problems, that fungicide seed treatment can be useful for us. Also, with Phytophthora, I mentioned that we do have different types of races out there in the field, and we do have several of those here in Wisconsin, and so we have to be careful to choose the right resistance genes in our varieties, and the RPS1K resistance gene seems to be effective in about 99% of the fields here in Wisconsin. So you're going to want to take some time to study not only the variety trials in terms of what performed well in a given year in your particular location, but you're also going to want to look at what resistance genes a particular variety might have available. Switching gears, another soil issue that we do see in soybean is soybean cyst nematode, which is caused by the nematode species Heterodora glycines. Now, warning signs that you may have soybean cyst nematode include these areas of stunted growth in a field, or yellowing that you might see in these locations. They can typically be localized, and you might have various patches throughout the field. Later in the season, you can oftentimes pull plants that have these above ground symptoms, and a lot of times you'll actually find evidence of the female nematodes in the way of these white cysts on the finer root systems of soybean. So sometimes that can be observed. And again, you can see how we might inspect plants. Again, you're not going to see this early in the season, but sort of mid-growth stages when we've had pods set, you can pull plants, dig them up, and find those cysts. Now, don't confuse these with, of course, nodulation on soybean. The cysts are much, much smaller than a typical nodule would be on a soybean plant. We also have recommendations in terms of how to sample for nematodes. We do offer through the Wisconsin Soybean Marketing Board some free nematode testing, and so you can actually pull a soil sample and have that sent into the diagnostic lab, and they can give you a count of the soybean cyst nematode population in that particular sample, and that can give you an idea of how serious the problem might be in a particular field. In terms of management for soybean cyst nematode, we want to use maybe non-host crops when we're in rotation there. And then we want to rotate with resistant varieties, and also rotate the types of resistance within the variety. So there are different types of resistance to soybean cyst nematode, and we don't want to use the same type over and over in a particular field, because that can place some selection pressure on that nematode. We might also rotate tolerant varieties with susceptible varieties, again, because that'll take some selection pressure off the nematode to switch to a race that might be less sensitive to the genes that we're using. We also want to relieve stress on those plants, and we want to supply good growing conditions to relieve any stress on those particular soybean plants in a field. And we want to monitor those cyst populations, because that's going to give us the best plan going into the season in terms of choosing varieties that are going to be useful to combat this problem. There's no in-season things that we can do for soybean cysts, so planning is everything with this particular disease. Probably one of the more important foliar problems on soybean in the state of Wisconsin is Sclerotinia stem rot, or what we commonly call white mold. And this can be significant in certain years, especially when we have very cool or moderate temperature conditions and a lot of humidity or rain around. Those are going to be the years that are going to be very conducive for this particular pathogen. When we reach temperatures up around 90 degrees or higher and it's very dry, we often don't see this pathogen around, so this isn't going to be an issue in every season, but can be in seasons, again, that are cool and wet. The pathogen here is Sclerotinia sclerotiorum. These little mushroom-like structures called apothecia give rise to spores. Once the canopy closes in a field, these spores infect flowers on the plants during the flowering period, and about 90 to 95% of the infections actually take place through these flowers. Okay, so the bloom period is very important in terms of in-season management for Sclerotinia stem rot, because that's when the infection courts are going to be there present. We want to protect those flowers. After the flowering period, the risk for infection goes down dramatically, and so we don't need to really worry about any in-season management after that bloom period. Here's some of the damage that we often will see. In very severe cases, you can have total plant death, where the stems are basically bleached or brown in color. The leaves might remain attached. You can see in this field in the lower right-hand corner here, pretty severe case of Sclerotinia. When the disease is active, we oftentimes see a white cottony growth, hence the name white mold when we're dealing with this disease, and a lot of times it can girdle the stem and cause death on the main stem. When the disease isn't active, we can still see damage from the fungus here in the way of these bleached or sort of a brown paper bag colored lesion that can often extend up and down the main stems. Yield loss can be pretty dramatic for Sclerotinia stem rot. For every 1% increment of plant mortality at the R6 to R7 growth stage, we can have about 0.25 to 0.5 bushel per acre loss in yield. And so it can be pretty important to manage this particular disease, especially in fields that have had a history. Keeping good history notes on fields and scouting is going to be important for the following soybean crop that's going to be in that field, because you're going to want to choose varieties with good resistance. There isn't stellar resistance in the commercial realm right now for Sclerotinia stem rot, but there are some tolerant varieties out there, and I would encourage you to choose those varieties over some of the more susceptible varieties out there in fields that are at risk. Canopy row width and plant population can be important in managing this disease. If we can space out plants a bit and try to get less thick canopy, that will help reduce the levels of disease in a field. When we open the canopy up, it makes the conditions less conducive for the fungus, and thereby keeps the disease down to lower levels. Crop rotation can be somewhat important, although the sclerotia, which give rise to the apothecia, those sclerotia are actually the survival structures, and they can survive quite a period of time in the soil environment. Some literature says up to 10 years, and so crop rotation might not be as useful for this particular disease as it might be for some other diseases, but still can be important. In season, we do have chemical control in the way of fungicides, which could be used, and then there are also several biological control agents which can be applied to the soil after the crop has come out to try to reduce the level of sclerotia or those survival structures that we see. These biological control agents actually parasitize the survival structure and break it down so it's not viable. Maintaining good records, again, variety selection, cultural practices are all important here. If you're trying to go the in-season management route and you're trying to use fungicides, the R1 to R3 growth stage, so beginning flower to first initial pod set, is going to be very important, and that's going to be the window where you're going to want to apply a fungicide. After the R4 growth stage, applications of fungicide in our research trials have shown that it is not useful for controlling that disease. So your window, again, is between the R1 and R3 growth stage. Again, biological control can be useful. And then in fields where irrigation is being used, you're going to want to manage that irrigation and reduce the frequency, especially during the flowering period, because that also is very conducive for the disease. We do have a recent management guide for white mold that was developed by the North Central Soybean Research Program. So if you're looking for more information on white mold and management of white mold in the North Central region, you can visit my website where you might find a link to this particular guide. Another above-ground disease of soybean that we see is brown stem rot. Brown stem rot is, again, not going to be a problem in every year, but can be a problem in certain fields that are at risk and can be localized in some cases in certain fields. Losses from this particular disease were estimated to be 7.4 million bushels in 2005, and so it can be pretty significant in some years. Yield losses can range from 10 to 30% in affected fields, and the fungus survives in old soybean debris in the field, and so longer rotations can be helpful here with managing this disease. The pathogens which cause brown stem rot can come in two different types. We have the A pathotype and then the B pathotype. The A pathotype actually causes more foliar type symptoms like you see in the upper left hand corner here, where we have the interveinal necrosis and yellowing that we get with the foliage here. With the B pathotype, it's a little more complicated because we don't see the damage of the foliage that we get with the A pathotype. So we have to do a little more homework here when we're dealing with the B pathotype. Infection does occur over a wide range of soil conditions. However, greater yield reduction occurs when there's dry soil conditions during part of the season, and losses may be reduced in years with high rainfall or optimum irrigation, especially when it's early, and then if we withhold any irrigation or water later in the season. Soil pH can also be important for brown stem rot. Severity is greatest when pH is near 6.0 and less, and when pH is greater than 7.0, again, because this does stress plants. And so some soil testing and trying to manipulate soil pH here could help in problematic fields. Crop rotation of 2 or more years effectively suppresses the incidence and severity of this disease, so rotation can be very important here. And then resistance is no complete resistance has been reported for brown stem rot. However, there is some partial resistance out there, and we know that SCN resistance, or soybean cyst nematode resistance, from PI 88788 can be in part resistance to brown stem rot as well. And so when using those SCN types of resistance, that can be important for brown stem rot. Now, I should mention that if you're using the Peking form of SCN resistance, that group has been reported to be more susceptible to brown stem rot. So you have to do a little homework here and look at which types you have in a particular variety. Now let's contrast brown stem rot to sudden death syndrome. The foliar symptoms, if you have the A pathotype of the brown stem rot pathogen, they can look very similar. The foliar symptoms can look very similar to sudden death syndrome. So you need to do a little bit of diagnostic homework here to differentiate the two. And we have seen an uptick in sudden death syndrome in the last several years in the state of Wisconsin. Again, you can have that interveinal necrosis and damage from the above ground parts of the plants. But when we pull plants from the soil and observe the roots of plants that are affected by sudden death syndrome, we oftentimes see rotted root systems here, like you see in this photograph, and then oftentimes we'll notice a blue or purplish growth on the surface of that taproot. That is indicative of sudden death syndrome. So if you see the rotted root system and that purple growth, that could be sudden death there. Also, there's no internal stem discoloration that we get with sudden death syndrome. That is different than brown stem rot, and when you cut stems of plants that are affected by brown stem rot, you'll often notice a discolored internal pith section, which we do not get when we have sudden death syndrome. So this slide compares and contrasts the various symptoms that we might see with sudden death syndrome. Again, the foliar symptoms alone are not very good for diagnostic purposes in differentiating these two, so I would encourage you to pull plants and look at root systems and also stems. Go ahead and cut stems and look at the inner pith area. Again, brown pith would indicate brown stem rot. Rotted root systems here would indicate sudden death syndrome. Okay, so don't rely again on those foliar symptoms alone. Sudden death syndrome, a lot of times in the field, we also will a lot of times notice leaf drop in severe cases with sudden death versus brown stem rot where the leaves will be attached. And a lot of times the damage appears later with brown stem rot versus sudden death syndrome. So R3 to R4 we might start to see damage from sudden death syndrome versus R5 to R6 with brown stem rot. Again, I mentioned a little bit about the interactions of SCN with brown stem rot, but there is also some published research to show that there could be some interactions of SCN with the sudden death syndrome pathogen. Although in Wisconsin we know that when the two do appear in the same field, the severity of symptoms can be quite high. We do know that when you have SCN, that doesn't always indicate that you're going to have SDS. So you need to still look for both and do some homework there. But choosing varieties with good SCN resistance can also help you maybe manage brown stem rot and also sudden death syndrome in fields where you might have both pathogens present. We also have a management guide available. You can find this at this link here, or you can Google sudden death syndrome information, and you'll oftentimes find this guide coming up. Choosing high-yielding varieties can help when managing sudden death syndrome. Selecting varieties with good agronomics can also be important. Planting early, but in warm, dry soil can help. We don't want to delay planting too long, although there is some literature to suggest that delayed planting can help manage it. We don't want to take a yield loss from delaying that planting, so optimizing the planting window can be very important. Managing soil compaction and also using high-quality seed. Transitioning a bit to some different pathogens on soybean, we can have several viruses. Probably the most impactful or the one that we see commonly in soybean, although at not very high incidence levels, is actually soybean mosaic virus. You can see the kind of leaf stippling, we call it, with these symptoms on the foliage here. And then probably even more diagnostic would be these black to brown streaks that we oftentimes see on seed from affected plants. We know that the soybean mosaic virus can be aphid transmitted. It can also be seed transmitted. And plants with symptoms often have this rugose or stipple symptomatic leaf material here. Control is pretty much through variety selection and also choosing clean seed. So if you're a seed grower or deal with seed growers, you want to make sure you're looking at the seed quality as it's coming out of the field, and make sure you're weighing in and identifying any viruses that might be in that seed. With that, if you have any further questions about soybean diseases in the state of Wisconsin, you can feel free to give me a call at my phone number listed here. Also, my email address is available. And I also maintain a website where you can find more information about these diseases and other diseases of soybean, or you could contact your local extension agent.